Awesome. Hey there, everybody. We're going to talk today about how to graph linear functions in slope-intercept form. So there's a lot of terminology there, but we'll go through all of it. And slope-intercept form is any equation that looks like this. It takes that form. So the x and the y are the variables. The m is going to represent the slope of the line. And so I'll write this down. M is the slope. And the y-intercept, where the line is going to intersect the y-axis, is going to be the point 0, and then the b. So whatever number is added, the constant on that side of the equation. Now, we learned a lot about writing equations this way. We talked about linear functions earlier this year. We did y equals c plus ax. It's the same thing. The only difference is we switch what these letters are to fit what's more standard, and we also switched the order where we put the constant. We had put the constant first, and then the term with the x second, and now we just switch those. All right. So let's try a couple of examples with these, and I'll start with y equals 2x minus 3. And there are two ways that I can graph out of slope-intercept form. And if you want, you can rewrite the equation as what we're used to, putting the negative 3 first and then the 2x afterwards. So we had talked about negative 3 kind of being the starting value, and that's not exactly right because there's actually no start or end with these lines. But what I'm going to do first is graph the point 0, negative 3. Right, so the negative 3 is the b value, and that's where I'm going to kind of start. And I can use any point on this line as a starting point. I just have to know one of those points first. Now, we also know the slope is 2. Now, if you want to think of it as 2 over 1, go right ahead. You might have learned about rise over run, and that's fine too. But with the slope being a positive 2, what I'm going to do is I'm going to go 1 unit to the right, because that is the denominator of my fraction. And then I'm going to go 2 units up because the slope is positive 2. So for every 1 unit change in the x, we're going to go up 2 units. I'm going to make a positive change of 2 in y. And now I have another point on my line, and then I can take those 2 points and connect them. And voila, there is our line. Awesome. All right, now that's a quick way to use slope-intercept form to graph. But if you forget this or you're not comfortable with it yet, there is another way. So I'm going to take the same equation. And since I only need 2 points to determine a line, I'm going to pick 2 values for x. I'll find what 2 of those points are. So let's say I let x equal 1. So I'm going to substitute 1 into my equation. I'm going to end up getting negative 1. So I have this point where x is 1, y is negative 1. And I'll plot it. There's 1 point. And then I can choose literally any other number to be another value for x. So if I wanted to, I can pick negative 1. It doesn't make a difference what these numbers are. But I will evaluate. I'm going to get negative 2 minus 3, and I get negative 5. So now the x is negative 1, and the y is negative 5. So I'll plot that. So negative 1 is 1 to the left, and negative 5 is 5 down. Kind of goes off my grid, but that's okay. And now again, I have 2 points that will determine my line, and I'll connect them. All right. And other than like how badly I drew these, you can see that those lines are the same. All right, and actually one of the points I had after using my slope was 1, -1. The same point I found here. It's a little off because my drawing wasn't completely accurate, but 0, -3 is one of the points on this line. All right, so let's try one more of these. Y equals -2/3 x plus 4. Now what I'm going to do with this one, if you want to rewrite this kind of more in that c plus ax form that we had done before, that's fine. If you want to keep it this way, that's fine too. And in most books, most resources, you go on YouTube, most of them will refer to linear functions in that order, right? But it doesn't make a difference either way. It's the same. The graphing is still the same. So I'll start by going to 0, 4. My y-intercept, so 4 is my b value. And now the slope is -2/3. So there are a couple different ways I can do this. The slope being -2/3 means that every time the x changes by 1 or increases by 1, the y is going to go down by 2/3. So I could say, I'm going to go 1 over to the right, and then 2/3 down. I'm going down because the slope is negative. All right, and that would give me a second point, and I'd have to figure out what that is. I think it's 1, and 4 minus 2/3 would be 3 1/3, or 10/3 if I change it over to a mixed number. And I could connect those points and have my line. The other thing I can do is this. You might have learned again about slope being rise over run, so I could say, all right, fine. The run, the horizontal change is +3, and I'll start my 0, 4, and I'll go 3 to the right, and the change in the y would be a -2. That's that rise part of it, but it's actually not a rise, it's actually a fall. So starting at 0, 4 and going 3 to the right brings me to +3 for an x, and going down 2 brings me down to +2. So 4 and then down 2. And now I've got, actually both ways, I got the same line. I got those 3 points on the same line. I'm going to connect them. And we're done. So we learned how to graph linear functions using slope-intercept form. We learned how to do it by coming up with values for x. And this, by the way, works for all linear equations. You can just pick 2 numbers, substitute and get your answer. I also noticed that when I had a positive slope, the line goes up from left to right. When my line had a negative slope, the line went down from left to right. So the fraction doesn't have anything to do whether the line goes up or down. It was the fact that it was a negative slope that made it go downward. All right, so hopefully this helped you, and this is a start to graphing linear functions, and I hope you stick with this because I know you can do it. All right, so thanks a lot. Have a good night.